We'll now be discussing our next question, that is question number 96. See, the question is, in the neutral or faintly alkaline medium. Okay, so the medium is neutral or faintly alkaline. KMnO4 oxidizes iodide into iodate. Fine. The change in oxidation state of manganese in this reaction is from. Okay, so here KMnO4 is acting as a oxidizing agent. Okay, and it is oxidizing iodide to iodate. So iodide is I minus, and that is getting oxidized to iodate, which is iO3 minus. This is the oxidation. But what is the change that KMnO4 is going through, or basically manganese is going through in that KMnO4? So basically in faintly alkaline or neutral medium, manganese, that is KMnO4 has manganese in its highest oxidation state, that is +7. So this is the oxidation state now, but since it is acting as an oxidizing agent, it will be reducing itself. So that means it will have the oxidation state of manganese will decrease. Okay, so it goes from +7 to +4. So that is what the question is. In neutral or faintly alkaline medium, the transition is from +7 to +4 oxidation state. So the answer that is correct is option number 1. So let's move on to the next one. Next question is from the environmental chemistry part, and it is, the pollution due to oxides of sulfur gets enhanced due to the presence of, and we have options. Options are particulate matter, ozone, hydrocarbons, and hydrogen peroxide. So here when sulfur forms its oxide in the air, it is SO2. Okay, so this is the SO2, and actually this SO2 gets converted into SO3, sulfur trioxide. So here what makes it get that conversion? Here if you see, the particulate matters present in the air that acts as a catalyst and helps in the conversion of SO2 to SO3. So basically that is nothing. Secondly, if we'll talk about some other molecules that helps in conversion. So apart from this particulate matter, we have ozone also doing the same, and as you know, ozone is a great oxidizing agent, so it can turn SO2 into SO3. Hydrocarbons, no, they have no role in that. And let's talk about hydrogen peroxide, and again we know that peroxides are good oxidizing agents. So here peroxide can help the SO2 molecules to get oxidized, and hence we have all the three possibilities for this conversion, and hence the correct options here would be A, B and D, and I think that is option number 2. So this is the question that was asked. So let's continue to the next one. Okay, so next is, again there are statements. So given below are two statements. Statement 1, in Lucas test, primary, secondary and tertiary alcohols are distinguished on the basis of their reactivity with concentrated HCl and zinc chloride, ZnCl2, known as Lucas reagent. So as we know, Lucas test is basically the test to distinguish the different degrees of alcohol. It's like primary, secondary or tertiary. So here we have the same thing, and this reagent is called concentrated HCl along with zinc chloride is called Lucas reagent. So that is totally correct. Let's come to the statement 2 part. Primary alcohols are most reactive and immediately produce turbidity at room temperature on reaction with Lucas test. So what happens when Lucas reagent comes in contact with alcohol? Let's say we have some alcohol, and this alcohol reacts with the Lucas reagent, that is concentrated HCl. This is concentrated, and we have ZnCl2. So here this alcohol gets converted into alkyl chloride. Okay, so this alkyl chloride produces the turbidity. So here will the mechanism that is followed is SN1, and here the tertiary alcohol gives it the most easily. Like here if you'll see, tertiary alcohol gives the turbidity immediately, whereas secondary alcohol takes some time, like 5 to 10 minutes. And if we'll talk about the primary alcohol, it do not give the reaction. It do not give any test with this reagent. If we need to, if we want to convert that or carry out that test, if we'll heat it, then in that case only the primary alcohol will be converted into the alkyl chloride. So in normal conditions it is not given, so the option is actually incorrect. Primary alcohols are most reactive, that is wrong. The reactivity order is tertiary, then secondary, and then we have the primary one. So that means option 1 is correct, statement 1 is correct, but statement 2 is incorrect. So I think it will be 1 correct and 2 incorrect, option number 3. So that is the right answer. Okay, so next one. Copper crystallizes in FCC unit cell, solid state. Yeah. So copper crystallizes in FCC unit cell with cell edge length of this. So this is the edge length of that unit cell. Fine. The density of copper is 8.92 gram per centimeter cube. Calculate the atomic mass of copper. So we have to get the atomic mass of copper, and we are given that copper crystallizes as FCC unit cell. See this carefully, FCC unit cell. So the edge length for such unit cells given are 3.608 into 10 to the power minus 8 centimeter. Okay, density given is this. So we have a formula for density, and that is D equal to Zm upon A cube Na. Okay, so here what are the parameters, what are the terms? Z is actually the number of effective number of atoms present in the unit cell, and for FCC I think everyone knows, you must be knowing that for FCC Z value is 4. 4 atoms are there that makes up the entire FCC. So Z here is 4. Okay, fine. We have to get the molar mass. This is molar mass taken in gram per mole. Okay, A is the edge length, and here A is given directly, that is 3.608 into 10 to the power minus 8 centimeter. Okay, and Avogadro number you all know is 6.022 into 10 to the power 23. That is the Avogadro number. Density here given is 8.92 gram per centimeter cube. So here the edge length is in centimeter and density is also using the centimeter term. So basically what we can do, we have to get this, and for this we can write that molar mass equals to density D into A cube into Na upon Z. So you have to put the data here. Density is 8.92. Okay, fine. Edge length, that will be taken in centimeter only. This cube, okay, and next is Na. You know the value, that is 6.022 into 10 to the power 23, and this whole thing will be divided by 4. So on solving this, you'll be getting the answer that will be 63.1, and we also know that copper has similar molar mass. That means our answer is absolutely correct, and that is 63.1 U, that is unified mass. Okay, so move on to the next one and the last question for chemistry section. Okay, so we have a question here, and we are given benzene nitrile, and we are asked to react this with lithium aluminium hydride, LiAlH4, and water is there. So basically lithium aluminium hydride is an excellent reducing agent, and that will turn this cyanide into amine. So the reduction process will be bringing up this, like benzene will be as it is, and here you will have CH2 NH2. So, this is basically a primary amine, that is 1 degree amine. So, this is 1 degree amine. The next reagent here is NaNO2 with HCl. Okay. So, NaNO2 and HCl is there, and we have a primary amine. Temperature is not mentioned, and you know that this is aliphatic amine, and aliphatic amines, this basically under this will bring down the diazotization part, and after diazotization the diazonium salt will be formed, and the salt will be like this, N2 plus and Cl minus. But we know that diazonium salts are not stable, and especially this is aliphatic. So, if we lower the temperature to 0 to 5 degree also, it is not going to be stable. So, basically this is not going to be like this. Water will be attacking here and will be expelling this out. So, here you will get this compound, and this is nothing but the benzyl alcohol. So, the option correct is option number 4. So, this was the part, the chemistry part from NEET, and we are done with the solution. So, thank you.